This is a video from section 1.3 in a linear algebra class. Prove. If A and B are n by n matrices, show the trace of A plus B is equal to the trace of A plus the trace of B. Let's take a look at the proof. What do we know? Let A and B be n by n matrices. Let A11, A22 through ANN be the entries along the main diagonal of A. Let B11, B22 through BNN be the entries along the main diagonal of B. Now, you want to ask yourself, what does the trace of A mean? And what does the trace of B mean? Well, by definition, the trace of A is the sum of the entries along the main diagonal of A, of matrix A. In other words, the trace of A is A11 plus A22 plus all the way through until ANN, but I would encourage you to write this in summation notation. And that's the summation from I equal 1 to n of AII. In a similar fashion, the trace of B is equal to B11 plus B22 plus all the way through till BNN. And in summation notation, that's the summation from I equal 1 to n of BII. Now, remember what we want to show. We want to show that the trace of A plus B is equal to the trace of A plus the trace of B. That's what we're trying to show. So what I would do is start with the trace of A plus the trace of B. But isn't that the summation from I equal 1 to n of AII plus the summation from I equal 1 to n of BII? Okay. But by the properties of sum, we can write this as the summation from I equal 1 to n of AII plus BII. But let's note, by definition, isn't the summation from I equal 1 to n of AII plus, that should be an I, plus BII equal to the trace of A plus B, right? And so that implies the trace of A plus B is equal to the trace of A added to the trace of B. And so the key step on here is going from here to here. And that's using the properties of summation notation. When you add a finite sum, we're allowed to do that. So, okay, that'll conclude this video for section 1.3, and we looked at a problem from the homework where we proved the trace of A plus B is the trace of A plus the trace of B. Okay, thank you.